In today's demonstration, I want to show how we can use a dual channel model 2602B to perform a DC current gain or hFE test on a bipolar junction transistor using our KickStart software. Now here in the diagram, I've shown kind of the connections here where one of the channels of the source meter is going to be used to apply a voltage bias at the collector terminal, and then it will also measure the collector current. The second source meter channel will inject current into the base of the transistor to turn it on and affect this collector current. And as we know, the hFE parameter is just simply the ratio of the collector to the base current. For the 2N3904 part that we're going to be using today, the datasheet tells us that we want a 1 volt bias on the collector. We want to adjust that base current until we get 10 milliamps of collector current, and then the ratio of those two currents should be between 100 and 300 for the hFE parameter. So using those values, 100, a gain of 300, collector of 10 milliamps, that means we should need only about 33 microamps, but if we're at a lower gain device, then we could need as much as 100 microamps to do that. So let's set that up. So here's the KickStart software. The model 2602B dual channel source meter has been detected on a USB bus. I'm just going to take that and drag it out here, and then KickStart will offer the IV Characterizer app as a compatible piece of software for this hardware. Okay, so here it's presented me with the GUI interface for configuring this test. I'm going to just put some new labels on these SMU channels to make it a little more intuitive once the data start arriving. So my SMU channel 2 is to the collector, and SMU1 is to the base. So coming back here to the base, so as discussed, we want to inject current into the base, a sweep, and I'm going to go ahead and start it as low as 10 micros, which was a little lower than our 33 micro minimums we thought we might need, and then up to 100 microamps. And over here on the number of points, if I set it to 91 and then click out of there, you'll see that gives us a nice even step size. So we'll start at 10, 11, 12, and so on until we get to the 100 microamp last value. When we force current, then there's a voltage compliance limit. And in this case, that would be the maximum voltage that the SMU would apply to the base emitter junction on this device. Okay. I am wired with 4-wire connections, so I'll click that box, and then I prefer a voltage output off mode for that. Okay, that's good. Let's give the collector the focus here. So now we do want to apply voltage to the collector, but not a sweep. We just want a biasing condition of 1 volt. Now, since we're forcing voltage, the limit is a current limit. So this would be the maximum permitted collector current. From there, 100 milliamps. I'll go with that. That's a lot higher than we're going to need. We expect to come in around 10, with this hFE test. And again, I'm 4-wire, and I prefer that setting. Okay, I think we're done. Let's give it a run. Then you see in the table, the data arrive, the different base currents, the 1 volt collector, and then the resulting current. Let's look at it on a graph. Let me set this up. I want to plot the base current versus the collector current, and there it is. So we can place a cursor here, and I'm going to adjust it so it looks like there is kind of our 10 milliamps of collector current and required the 45 microamps of base current to get that value. So the ratio of those is going to put our gain within those bounds of between 100 and 300. So I hope you found this useful to understand how to perform an hFE test on a BJT transistor using the KickStart software. Thanks. Bye-bye.